Here we go. Thank you.
Thanks for the introduction and thank you for being here. I'll have a presentation soon. So I, of course, as you might expect, am also an EV driver. So back in 2021, I bought my first EV, which was a demonstrator Leaf from Victoria in the height of their lockdown. Had a great experience with that. Now, that's not actually the right slide. Okay, there we go. Yeah, had such a good experience with that. Never had any issues, and then decided that we could get an EV that would do everything we needed rather than just a commuter car. So we ended up with an Ioniq 5, which we're very happy with. And in between, we upgraded our solar on our house to 10 kilowatts, which means we charge effectively for free, or very cheaply most of the time. And we now have 5 adults in our family and only 3 cars, 2 EVs, 1 hybrid. So we all know EVs are inevitable. That's not a curve that's going to head south anytime soon. So I think everybody believes that. The question is, when's it all going to happen? When does it start becoming difficult? Where geographically, and how ready we're going to be. And of course, build it and people will come. If everything works well, then they'll be happy to move to EVs. If it's not a great experience and there's all sorts of challenges, then maybe not. So today I'll look at Tassie and its energy system through hydro, the predictions of growth, and what hydro is doing with its own car fleet as well. So we all know Tasmania's unique. Our hydroelectric system is also unique. Tasmania's a small island. Our journeys aren't that long. Typically you can get anywhere in Tasmania with a current model EV with only a small stop somewhere maybe. It'd be the most you need to do. No one's doing a 1,000 kilometre in a day trip in Tasmania. The mountains disappear with an EV. You don't lose efficiency like you do on a windy mountain road in an ice car. And so hydro system, we have 30 power stations around mostly the central area of the state. We have 52 large dams, hundreds of other significant assets. And we're connected not just physically to the mainland through Basslink and in the future through Marinus, but also connected with the community and very engaged in this transition. So as far as evolution of hydropower goes, so more than 100 years of development, when things were very much hands-on with teams in all the stations. These days much of it's automated. We still have people spread around the state. There's been a great increase in wind power over the last few decades. There's a lot more that's in planning at the moment, which is important. We're connected to the national market. We still have significant gas backup when it's needed, up to 432 megawatts, I think it is, of gas. Good solar growth in Tasmania, and we're going through a round of machine and station refurbishments for better reliability and more efficiency. But we're facing a climate change challenge. So some of the vital stats, so Tasmania has 2.3 gigawatts of installed hydro. There's also 500 megawatts of installed wind power under various owners. Typically in winter a peak is 1.5 gigawatts. We like to have a full Basslink of around 450 megawatts ready when the timing is right to export through Basslink. And in 2024, hydro alone generated 7.7 terawatt hours. There was wind power on top of that. There was a bit of gas here and there as well. There's obviously import and export across Basslink too. But the typical consumption in Tasmania is around 11 terawatt hours in a year. So this is work done by CSIRO and adopted by AEMO in the integrated system plan. So looking at these couple of graphs here and looking at CSIRO's comment there that new sales will probably be 70% by 2030. That's not very far away to be 70% EVs. And maybe not 100%, there'll always be edge cases. Not everyone can have an EV. So by 2040, obviously mostly EVs. So even if we pick a number like 75% of sales being EVs, which sounds reasonable in the future, that could be happening under different models by about 2040 or even earlier. It's 70% EVs being sold in the market. Again, looking at that 2040 date, that would imply the EV share in the country of being somewhere between 40 and 60%, possibly even more EVs, similar to what that headline said. So we're on our way, we're nowhere near there. So at the moment we're down in visionaries and early adopters, if you like. So there is a big jump to get all of the other people who are waiting for it to be a car to be cheaper to buy, or for it to do absolutely everything they need, or to swap out their second vehicle for an EV or whatever it might be. And of course, a lot of people in the tail end to bring on board. So there's a lot of work to do. And Tasmania does have some particular barriers that might see us being a little bit behind. So 7% of sales is still, that's up there. These days you see EVs all over the place. But we do have the oldest car fleet in the country. And these factors tend to relate. So the oldest population in the country. We have health issues as well, which might not play into it so much, but we also have lower income in Tasmania. So they're all things that might result in a lower or slower uptake of EVs. And EVs may take longer to trickle down into the used market, as in second, third hand. And there's still a lot of confusion with the misinformation and deliberate disinformation that's out there everywhere, and confusion over what the real cost of owning an EV is, confusion over what total cost of ownership means and how you equate upfront the cost versus reduced operating costs. So things that aren't necessarily barriers for Tasmania is we do have good rooftop solar penetration. And looking at the chart on the left there, that's showing that there's very high growth of solar installations in Tasmania, higher than anywhere else. And part of the reason for that is that if you look at the right curve, we're not actually that far behind on what we generate from our solar in Tasmania compared to other countries. So we do, other states, so we do very well. And of course, there's a lot more choice. As we see these days, prices are a lot lower. You can get everywhere you want to with the range of a current vehicle. You're not limited to maybe 200 kilometres in a 40 kilowatt hour car these days. And there's enough charging to get anywhere you need to generally, but still need to obviously increase that. So does hydro need more power to push through the peaks, or do we need more energy to get us through a year? And we do need a bit of both, but mainly it's an energy challenge for us, but not too much of a challenge. But a big issue is climate change, which is a quadruple whammy for us. So less rain, so it means drier catchments. When it rains, less water runs into the storages. It's all very unpredictable, and when we get big rains, we sometimes end up spilling it, so we lose some of that water anyway, so it's lost energy. If we look at the impacts on the national market, so the southeastern states, then the work by CSIRO was telling us 40 to 60% EVs by 2040, which again is very close. These are numbers that some of you might understand, but 25 to 40, looking at the chart on the right there, terawatt hours for EVs, which is 3 Tasmanias basically, just to run the EVs in the southeastern states, which is significant. And of course, that's only part of the electrification journey. So around 100 terawatt hours per year for electrification of industry, getting other states off gas networks and onto heat pumps and electrifying everything. So if we look at Tasmania, believe it or not, we do have 600,000 cars. They won't all become EVs. I'm sure a lot of them don't do much work, but we still have hundreds of thousands of cars to convert over the years. So if CSIRO is saying 40 to 60% EVs around the country, Tasmania will likely be a little bit behind that. So probably 30 to 50% EVs by 2040, which the figure we're working to is that's around 270 gigawatt hours per annum, so around 2.5% of what we currently consume, which is about the same as our increase in load in a typical year, I believe, due to population growth and other things, somewhat balanced by efficiency improvements, but general electrification is in there. So it doesn't sound that challenging, but it's on top of other things. So if we look at the power challenge, this is a fictional scenario of 100 big DC chargers in the future with higher capacity vehicles. Then that's 30 megawatts. That's a very small machine for hydro. We have machines that don't get out of bed for 30 megawatts, and most of ours are bigger than that. And a more significant situation is AC charging. That's the old, what if everyone gets home from work and all plugs in at exactly the same time? If you had 50,000 cars all plugging in together into what might be 22 kilowatts, if they're all big cars in the future that consume a lot of power, 1 gigawatt. It's basically impossible. That can never happen. It's a ridiculous situation. So we're more likely to see peaks of around 10 megawatts to supply DC fast charging, which is just a ripple in a day for us. More significant for local distribution perhaps, but not such an issue for hydro generation. AC charging, if it's scheduled, but still mainly happens in the nights. Again, it's around the 30 megawatt sort of a figure, which is, again, not that significant for us. And because we're so responsive, machines can pick up load very readily. Not much of an issue there. But the additional energy of finding 270 gigawatt hours is a more significant challenge. So it's general knowledge that any big industry that comes to the state really needs to bring its own energy, which can be backed by hydro. So we can fill the gaps in VRE, variable renewable energy, but we still need extra energy in the state, so we don't have to import more. So the solutions are the sort of work we're doing now in increasing response and reliability and efficiency of what we do have, which gives us more power and more energy. Time of use tariff encourages good behaviour of charging cars from your own solar rather than twice the cost to charge from off-peak or during off-peak, or 4 times that cost to charge in the peak. There's an opportunity for demand signalling of vehicles charging at times when load is low. And of course, building new pumped hydro storage will provide the opportunity to store excess energy when it's generated, as well as providing more power into the system when needed. So we still need more energy. So that will, over time, continue to come from increasing rooftop solar. We now have our first grid-scale solar farm in the north of the state too. More wind, so potentially wind could multiply by a factor of 5 with what's in planning at the moment. So a great deal more energy from wind. Storage in everything from home batteries to EVs to, again, pumped hydro. And additional interconnection. So when the prices are right, we can be importing, and when the prices are right, we can export, which is good for the state. So if we look at our hydro fleet and what we're doing now, so our current fleet, if we look at the ones we can readily change out, which are our passenger vehicles, so of our 280 vehicles, we have 140 or so, I think, which are vehicles that can be replaced with what's in the market at the moment. All of our sites, we have people spread around the state, but all of our sites are roughly 300 kilometres from Hobart, typically. So 300 kilometres is almost a median journey for us to the different distant centres that we go to regularly. And because people travel in the dark, we need vehicles that are reliable. On gravel, we need all-wheel drive vehicles, a bit of off-road as well. So now we do have vehicles that are suitable. And the reason we're doing it, of course, is very consistent with our purpose, vision and strategy. It gets us out there and visible. It encourages people to buy our product, in effect, but we're doing it for all the right reasons to reduce our emissions towards net zero. So in building a fleet, we wanted to diversify the vehicles we have, not put all the eggs in one basket, try different vehicles and learn from those and help our people to learn. We definitely needed to have those attributes of capable vehicles that did most of the things that our typical all-wheel drive SUVs would do. And we also need to install charging. So we installed different DC chargers from 22 kilowatts, I think in 50s as well. We're about to install 1 or maybe 2, I think, 150 kilowatt chargers as well for our own use, which will be there for our longer journeys, which will take the load off having to charge in Hobart. So you can leave with 30% and you can charge on the way, rather than what we typically do, which is every car leaves at 100% to maximise our range and reduce the risk of bad experiences. So we cop the degradation on batteries and always charge to 100. So you can see there the vehicles we have, and there's a few of them out in the forecourt, so hopefully you saw those. So we're 16% of the way there out of our 130 light passenger vehicles that we have. We also have vans. We'll be looking at other things as they become available as well. So particularly utes and more economical cars. So of course we did consider what will people think when hydro people are driving around in luxury Volvos. So we do have 2 Volvos. That's what we could get at the time. And the response has been positive. But as there are cheaper vehicles around, we'll be getting those if they're just as capable and have more ground clearance, good four-wheel drive systems, etc. Bigger batteries will certainly help us to get to our remote places and back, but all of our power stations will have chargers, so it won't be such an issue. And we'll continue to roll out charging. So just to summarise, we're driving the change by changing how we drive and what we drive.
Questions, anyone? We're only going to get Hydro Tas on stage. And thank you for sponsoring too. And thanks for coming
You're welcome.
along. Yeah, it's really good. It reminds me that 2017, the nice man from Hydro looked at the polls outside and said, no one ever expected that we would generate and send to your house and that you would send it back to us. What an amazing challenge, and thank goodness you're here doing it. Some questions? Young man, you've got that look in your eye. Hold on, I'll bring you the microphone so we can hear what the question is.
Question, but okay, you mentioned at one stage everybody charging at once. How does that work from the household? If they're all just trickle charging, or if they're all level 1 charging, how does it work?
Well, I've had EVs for 3 years, and I've charged once in peak time when I had to race home to do something. I hadn't allowed for that trip, and then I had to charge at peak time and then go again. So otherwise, all my charging is in off-peak, or when the sun's shining, it's my own sky power. So typically, at the moment, it's off-peak time from 10. Most people would choose to do that anyway. As more people adopt or move to time of use tariff, then automatically that charging happens in off-peak times.
That'd be the case pretty much consistently. Has anyone got an EV that they think, oh wow, I'll charge it at peak time? No? Everyone on solar and batteries at home? Not yet? Would you like to see the ANZ just down the back there, sir? I'm sure you'll get a good price working for Hydro Tas. Young man, did you have a question? You've been here all day. Something you wanted to know? Hang on, I'll come over with the microphone so we can all share your joy.
Seeing that you've bought and sold an EV, what is the depreciation?
I'm yet to sell an EV, so we still have our Leaf. But I'm anticipating we'll keep them for quite some time, because we have 5 drivers with 3 cars, 2 EVs, 1 hybrid, and they're all going fine. But in 10 years' time, I imagine that the depreciation is not going to be much more, or would be less than what an ICE car might be, once 70% of people are wanting EVs and petrol is potentially more expensive, and we all have more solar. I'm confident I'm on a winner anyway with 2 of them, so I'm committed.
Even that Leaf over there is only $19,990, and people are saying, oh, the EVs cost too much. How much money did you spend on petrol last year? And what would that do to a repayment on either a novated lease through your employer or down with the ANZ? And the solar panel battery deal from ANZ, that'll get launched in 2 weeks' time. We're right at the cutting edge, aren't we?
It's exciting.
Yeah, it is. It is. The Norwegians were with us last year, and when they started at the same level as us, there was a whole heap of plucky volunteers who were engineers, who were the early adopters. Now they have 66 staff working on electrification full-time, and that's why 97% of their cars are electric. And we'll get there too. And the guy showed us to the day when it starts to go like that. And still our media says, oh, they're flattened. And it's like, I sat behind a semi-trailer with 5 Teslas on it on the way down. It's like, oh, don't tell those people. And Tesla opened a shop in Hobart. Morto bene. I mean, it couldn't do anything more. How's Hydro noticed any increase? Because obviously at the conference yesterday they said, no, there's not been an increase in power from charging with the cars. Is that still the case, Andrew?
I think it's possibly that we can't identify what would be from cars, and at the moment it's quite small. Yeah. So even in the future, at 2.5% of what we produce or consume in the state these days, now it's just a minor ripple. Yeah. So I don't think it would be noticeable.
Are we going to get any more dams or micro hydro? Where's the future? Obviously, Mr. Tomlin at Ellendale's now got his own 2 electricity stations. Is that something that any of us could do if we were on the Derwent, or should we be putting our own mini wind in, or how does it all work?
Not my area, unfortunately, but I'm sure subject to any approvals.
But Hydro would welcome it, obviously. Every bit of power that we generate ourselves allows you to distribute to the big users.
anything that ends up in the hydro network and with Tas networks can be redistributed,
Yeah,
of course. Yeah. And any home solar that's connected to the grid is there for your neighbours or someone at the other end of the state to use. It all goes in the same big pool. But as far as dam construction, I don't think hydro will be doing much other than what's associated with pumped storage for pumped hydro to give more capacity to put more power into the market when needed, and also more storage. So providing the double benefits there. But otherwise, wind power and additional solar, be it grid scale or on houses, is really going to be key to more energy in the state.
Do you get involved in that, Mr.